We'll proceed in pseudo calculus problems. Okay, so historical discussion we are pursuing in pseudo calculus problems. How we can solve a problem. Okay, I'm not saying that how we can solve a kind of a problem in calculus. So that matter of discussion is not how we can solve problem in calculus. The idea is how to solve a problem. Many times we don't need calculus, and many times we need calculus. When we know that we don't need calculus, and when we know that we need calculus. So that is the concept. When we know we need algebra, and when we know that we need vector. Anyway, so in that fashion, but we need numerical science. Numerical science has is a pillar of mathematics, and 99% of the weight of mathematics lies on numerical science one. Okay, in 1% there is algebra, and then there is calculus, and there is vector. Only in 1%. Otherwise, it is more or less numerical science only. But still, sometimes we feel that we have to cross the numerical science. But the concept, everything, it sits upon the numerical science only. Anyway, now we were in phase of calculating. Hope, all gone. Okay, so we are in phase of calculating a kind of angle. Angle. If I have a line, then what is the equation of other line at a particular angle? Okay, so if this is x-axis and I have a line like this, and this is at 30 degree, what is equation of this line? This is 30 degree. This example looks very simple, okay, but it digs out many things, that how a person can start working and how he can solve a problem. So consider, we will take many things in physics, in mechanics, and then everywhere we will take example, and then we will solve it without calculus. With calculus, there is no difference between without calculus and with calculus. Why calculus come, that we will talk. So this is x-axis, and there is a line at 30 degree. Okay, now from this line I am drawing another line at 30 degree. Okay, how this concept came is that consider that I have a point here. Consider there is, this is origin. This is origin, and I have a point here called 2 comma 3 comma 4. Make sense? This is origin, and there is a point called 2 comma 3 comma 4 somewhere here. Someone can draw a vector like this, a line like this to origin. I have another line. I have another line that is considered alpha comma beta comma z, alpha comma beta comma gamma. There is a point here called alpha comma beta comma gamma. If from this is origin, from origin I can draw a line like this to alpha comma beta comma gamma. This is 2 comma 3 comma 4. There is another line from origin. If I rotate this alpha comma beta gamma, question is that what is the new coordinate? What is the coordinate of a new point? If I rotate this point 2 comma 3 comma 4 along a line that is alpha comma beta comma gamma, or alpha I plus beta j plus gamma k. Okay, if this is the line, this line can be like this. Okay, and if I try to rotate this point, then it will rotate exactly around this line. If I say this is a point and this is z axis, still it is at not 90 degree possible. This is at some 70 degree. I want to rotate this point around z axis. This is one question. I want z axis is k vector. I want to rotate this point along any vector, that is alpha I plus beta j plus gamma k. This point is 2 comma 3 comma 4. If I rotate it 30 degree around this line, then what will be the position of new point? 2, 3, 4 will be transformed into what point? This is not available in any of the book. That's why I brought it. I have whatever I'm talking, I have not read anywhere. Okay, this is typically used in 3D graphics. Rotating means solution is there. Someone can use GL rotate where you can specify what angle you want to rotate along which line. Okay, if we say 1x, then it will be I plus half j, half plus k is 1 by 3. Then you are trying to rotate by 30 degree along a vector that is I plus, I'm sorry, that is 1i plus 0.5j plus 0.3k. This algorithm is hidden. It's not available anywhere else. We will publish a paper on this anyway. But what is the scenario that any point would rotate along any vector in 3D? Rather than coming to that solution, people can come to that solution. We will take simple example. Now we are only in XY plane. Only in XY plane. This is X axis and this is Y axis. This is XY plane. In this XY plane, there is a line at 30 degree from X axis. What is the equation of line? Okay, in that to find the equation of line, what we are talking equation of a line, then line has y, equation of a line typically has y by x, same everywhere. Straight line has y by x. If I take x here, then this is y by x, y by x, y. Everywhere y by x is same. What is y by x for this line? That is under question mark. What is y by x for this line? We are trying to find the line equation of a line that is at 30 degree. So by x, y by x means tan theta. Y by x means tan theta. What is tan theta? Okay, what is tan theta? Then y by x equal to tan 30 degree. Y by x equal to tan 30 degree. This is y, this is x, this is 30 degree. Y by x equal to tan 30 degree. What is equation of line? Equation of line is y equal to tan 30 degree. I don't know how much is tan 30 degree. That is sine 30 degree by cos 30 degree. Sine 30 degree, sine 30 degree is 1 by 2, I believe. And cos 30 degree is a square root of 3 by 2. It is 1 by a square root of 3. So y by x equal to 1 by a square root of 3. That is equation of line. Simple. Y by x is 1 by a square root of 3. What is equation of line? Y equal to 1 by a square root of 3 into x. What is equation of line is y equal to 1 by a square root of 3 into x. That is equation of line. What is equation of a line that is 30 degree from here? Again, this is at 30 degree. If I move 30 degree again, what is the equation of new line? That is under question mark. It is from 30 degree here. Now we will proceed more. I don't know. Anyone knows? Oh, I know. It is 30 degree, right? Then 30 degree. Okay, then 60 degree. So 60 degree, y by x equal to tan 60 degree. That is sine 60 by cos 60. That is square root of 3 by 1. Means y equal to a square root of 3 by 2 by 1 by 2. Y equal to a square root of 3x. That is the equation of line. Okay, but I am not looking for that kind of solution. What we are looking is, if I have any line equation that is y equal to x by square root of 3, I don't know the angle. Y equal to x by a square root of 3. From there, if I move 30 degree or any theta degree, what will be the equation of this line? That is under question mark. Okay, now when we are not able to solve any problem through normal algebra, y equal to x by a square root of 3 is the equation of this line, and I want equation of another line at 30 degree from here. Then if that is the case, then we move up numerical science to algebraic science, algebraic science to calculus. Algebraic science has two branches. One is calculus, to do the computation for the multiplication and division. If we want multiplication and division in algebra, where there are some corner scenario is there, we use calculus. Calculus is nothing but to calculate division, multiplication, addition and subtraction only. Calculus is just a name is calculus. It is a calculator only. That's it. Okay. If we want computation over a direction, angle, then we sometimes we use help of vector. Vector has nothing to do with calculus, and calculus has nothing to do with the vector. Calculus does multiplication, division, addition, subtraction for the algebraic equation only. And algebraic equation, if it needs direction, then we use vector. Okay, so we will try to use vectors. If someone is very excellent in algebra, he can find out. If this is the line of equation y equal to x by square root of 3, if I move any theta angle, here I say 30 degree, what will be the equation of new line? Okay, he can solve. Let's use vector. What is vector representation of this line y equal to x by square root of 3? Vector representation is very straightforward for any straight line. One end is 0 and other end is x comma y, then vector representation is xi plus yj. Very straightforward. Now, in that way, what is vector representation of this xi plus yj? Okay, in that fashion, for a straight line, vector representation, if I'm trying to find, then xi plus yj, this is what I don't want. Because since it is a straight line and y equal to x by square root of 3 is there, better we will have vector equation this line in numerical way only. In that sense, if in the there can be many way we talk here, but the basic vector is xi plus yj. I can do so many things here. Anyway, other fundamental is that if I take x as 1, if I take x as 1, then y will be y by x. Make sense? If I take x as 1, then y will be y by x for a line where y and x relationship is there. Make sense? If I say this point is 1 comma 3, means x is 1 and height is 3. At this point, y by x is 3 by 1. Make sense? Okay. At this point, I have x equal to 2 and y equal to 6. I can say this point is 1 comma y by x, that is 6 by 2. Any y by x I know for this line. Then any point which has x as 1, then y will be y by x. Or if I say xi plus yj, I can take out x. It becomes I plus y by xj into x. X I don't worry outside because it is not going to change direction because it will multiply in both places. So we have now I plus y by xj, that is the height. Equation of this vector is I plus y by xj. This is not a unit vector though. So this is same as xi plus yj. If I take the direction, okay, right now I'm interested in direction only. So it is I plus y by xj, but this will give the complete idea. What is y by x? Y by x is 1 by a square root of 3. This is y by x. Okay, in that fashion, the vector will be I plus 1 by a square root of 3j. Y by xj means 1 by a square root of 3j. Vector equation is I plus 1 by a square root of 3j. Okay, what is unit vector is? Unit vector is I plus 1 by square root of 3j divided by 1 square plus 1 by 3 square root. Okay, that is unit vector. Anyway, now I learned the vector equation of this is I plus 1 by square root of 3j. This is not a unit vector. Okay, now let's consider if I move 30 degree, then it will make another line. And this line has a vector alpha I plus beta j, which is a unit vector. Alpha I plus beta j is a unit vector. Now alpha I plus beta j dot product with I plus 1 by a square root of 3j will be magnitude of alpha I plus beta j, that is 1, and magnitude of I plus 1 by a square root of 3j, that we will calculate, into cos theta. Theta is 30 degree. 30 degree cos theta means a square root of 3 by 2. That is 30 degree. In that sense, it becomes alpha plus beta by 1 by square root of 3. I'm sorry, alpha plus beta by square root of 3. Alpha plus beta by square root of 3 equal to equal to magnitude is 1 square plus 1 by 3. 3, 3, 4. 4 by 3. 2 by square root of 3 into cos theta, that is square root of 3 by 2. All gone. 1. Okay, so equation is alpha equal to beta by alpha plus beta by a square root of 3 equal to 1. Alpha equal to 1 minus beta by a square root of 3. Another is alpha and beta are unit vector. Alpha I plus beta j is unit vector. Means if this is the line at 30 degree and I move 30 degree, it passes through a point. It passes through a point that is related to alpha. I won't say alpha comma beta, because if it passes through alpha comma beta, the vector is alpha I plus beta j, but it is a unit vector. Anyway, so alpha square plus beta square root equal to 1. Alpha equal to 1 minus beta square root, or alpha square equal to 1 minus beta square. Here we have alpha equal to 1 minus beta by a square root of 3. Alpha square equal to 1 plus beta square by 3 minus 2 beta by a square root of 3 equal to alpha square there. That is 1 minus beta square. Here we have 1 square. Okay, silently we'll solve it. So here we have 1 square plus beta square by 3. Square root of 3 square is 3. 1 plus beta square by 3 minus 2 by the square root of 3 beta equal to 1 minus beta square. 1 gone. Okay, now beta square, if I take this side, it becomes beta square plus beta square by 3. It becomes 4 beta square by 3. 4 beta square by 3. Okay, 4 beta square by 3. 4 beta square by 3 minus 2 by a square root of 3 beta. So beta gone. It becomes 4 by 3 beta minus 2 by square root of 3. That will go that side. 4 by 3 beta equal to 2 by a square root of 3. 2 and a square root 3 all gone. It becomes 2 by a square root of 3 beta. Okay, equal to 1. Beta equal to a square root of 3 by 2. I believe so. Something like that. Beta equal to a square root of 3 by 2. Okay, if that is the case, then what is alpha? Alpha equal to a square root of 1 minus beta square. Okay, in that fashion, it becomes 4 by 3. 1 minus 2 by square root of 3. So, okay, 3 by a square root of 3 by 2. Okay, this is what I think so. Beta was the square root of 3 by 2. 1 minus beta square root is alpha. 1 minus 3 by 4. 4, 3. Okay, it becomes 1 by 2. Alpha equal to 1 by 2. Let's see first it is a unit vector or not. Alpha I plus beta j is unit vector that represents the line, this line, next line. Alpha is 1 by 2. 1 by 2 I plus square root of 3 by 2 j. If that is the case, then it becomes, if I take magnitude 1 square plus a square root of 3 whole square, that is 3 by, I'm sorry, 1 by 2 whole square plus a square root of 3 by 2 whole square. 1 by 4 plus 3 by 4, 1. So it is really a unit vector. So we found the vector equation of another line, that is 1 by 2 I, that is alpha, plus the square root of 3 by 2 beta. That is the beta part, that is beta part, square root of 3 by 2 j. Alpha equal to 1 by 2, beta equal to a square root of 3 by 2, where we got this by merging two equations. One is alpha square plus beta square equal to 1, or alpha square plus beta square root equal to 1, because alpha and beta, they constitute unit vector. and another is dot product of this vector and this vector will be magnitude of this vector cos theta. From there we got one equation of alpha and beta. Anyway, if that is the way, what is beta by alpha? If I know alpha equal to 1 by 2, beta equal to square root of, we have not used calculus anyway. If alpha equal to 1 by 2 and beta equal to square root of 3 by 2, then beta by alpha is the square root of 3. Beta makes y vertical and alpha makes horizontal. I can say y by x equal to a square root of 3. Hop. Okay, even though it is not a unit vector or not unit vector, y by x will be same for unit vector and non-unit vector also. So beta by alpha is the square root of 3 by 2 by 1 by 2. That is square root of 3. Beta by alpha. Beta if I replace with y and alpha with x, then y by x equal to square root of 3. Y equal to x into a square root of 3. That is the equation of another line. Makes sense. Okay. So line that is perpendicular, that is at 30 degree from a line that is y equal to x by a square root of 3 is y equal to square root of 3 into x. Okay, to validate we will try 60 degree directly. If I take 60 degree, then y by x equal to tan 60 degree. And tan 60 degree is sine 60 by cos 60. That is the square root of 3 by 2 by 1 by 2. Square root of 3. Y equal to square root of 3x. It is exactly alright. So our fundamental to calculate the kind of vector by I plus y by x j is perfect. How to represent any line through vector is on x-axis take 1 and then height is y by x. If it is 1, then height is y by x. If it is x, then height is y. If it is 1, then height is y by x. Makes sense? Now, if any point is 1 comma y by x, then line passing from origin will be I plus y by xj. This is not a unit vector though. So actual equation, actual vector representation of a line is xi plus yj, considering line is passing through a point x comma y, origin x comma y. If line is passing from origin and x comma y, line passes like this, then in that fashion, this is xi plus yj. Xi plus yj can be written as I plus y by xj bracket closed into x. If I am thinking about direction only, we can discard x, not required. If I am thinking about direction and magnitude, I have to keep x. So a vector representation of a line is xi plus yj, considering line passing a point x comma y, or I plus y by xj bracket closed into x, or 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 I plus y by xj, only direction if I talk, or division I can convert into differentiation and multiplication I can convert into integration. In that fashion, it will become I plus dy by dxj bracket close into dx bracket close into x will change into dx. Okay, thank you very much. So this is what is the kind of uh, 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 okay. So you change y by x to dy by dx and into x into dx, right? Yes, right. Okay, where we can use this? Right now we don't need it. Why we did not need it? Why we did not need it is that we had everything straight line. If there everything is straight line, then if I do y by x, it becomes a numeric. If I do y by x, it becomes a numeric. Okay, when it will not become a numeric, that is another scenario. One scenario is y by x is becoming numeric. If y by x is numeric, then I'm not saying that we cannot use calculus or we have to use numerical. Why? Where we use numerical? Okay, where we need calculus then? If we are not if we are able to solve our problem without calculus, then where we need calculus? So that is a question. Okay, now actually we will take one more example. If I have a sinusoidal wave, if I have a sinusoidal wave, consider this is sinusoidal. Consider this is sinusoidal. This is this is x-axis. This is x-axis. Then this is origin. If this is origin, then this is sine wave. If this is sine wave, this is sine wave, and this is sine wave. This is origin, and this is sine wave. Typically sine wave. If this is a sine wave, what is this is a sine wave? Means there is a curved line called sinusoidal. What is the formula of this line? First of all, let's find the formula of this line. I know that this is y equal to sine x. This is what is given to us. Y equal to sine x is a formula of a curve y equal to sine x. What is the equation of another line that is perpendicular to it? Immediate answer will be cos x, because cos x is at 90 degree from sine theta. 90 degree, if this is x axis, then this is 90 degree y axis. If they are at 90 degree to each other, means they are orthogonal. So orthogonal at 90 degree, if I calculate a line from sine x, it will be cos x. Is it really true? Let's see what is the what we are trying to find out. If this is sinusoidal wave, if this is sinusoidal, then what is the 90 degree of this line? If I take any point, this is x-axis, this is x-axis, this is origin. If I take any point x, it will go and hit here. At this point, what is the line? What is the direction of the line? That will be tangent at this point. What is the direction of line at the peak? That will be exactly flat. What is direction of the line at this point? That will be tangent at this point. At any point x, if I take direction of this line, then I am talking about equation of another line that will be at this point. Consider direction of this line at this point, direction of this line when x is x. Direction of this line is like this. I'm trying to find equation of another line that will be exactly perpendicular to the it at same x. Consider this is another line that we are thinking it is perpendicular to the sinusoidal. At this point, sinusoidal tangent what like this. At same point, if I go to this perpendicular line and calculate the tangent at that point, they should be at 90 degree to each other. Right now they are not. Both are in same direction looks like. If I take other way, then here same point if I take at x, then it will be like this and it will be like this here in sinusoidal. Looks like they are perpendicular to each other. How to find equation of a line that is perpendicular to the sinus? If I take cos, let's take what is the vector representation of sinusoidal. Then it will be easy to find that how we can find. If I take sinusoidal, then if I remember, if I had a straight line y equal to x by a square root of 3, how we find vector representation of this line? 1 into 1 is x, then height is y by x. I plus y by xj is the vector representation of a straight line. 1 and height is y by x. I plus y by xj. I plus y by xj. That is the way. This is not a unit vector though, but still this is the vector representation. What is vector representation of line y equal to sine x? I don't. For a straight line, I understood that it is I plus y by xj. Because if I take any point on the line at x comma y, xi plus yj, if I take out x, again it becomes I plus y by xj only, multiplied by x. That I can leave it out. So I plus y by xj, this is pseudo calculus problem. Whatever we are going through, same fundamental we will proceed. Calculus is not a neighbor. Calculus is a member of your house only. Calculus is not a neighbor or a foreign body. Let's use calculus. Calculus is there only. Calculus facilitates solving a problem. Calculus is not a separate concept. Vector facilitates solving a problem. Vector is not a separate concept. Algebra facilitate solving a problem. Algebra is not a separate concept. Main thing is numerical science. To facilitate solving a numerical science, algebra comes. To facilitate solving an algebra, calculus comes. To facilitate solving an algebra, vector comes. At the end, I wanted perpendicular to the line that is y by x by square root of 3. I wanted a line. To make it life easy, we use vector. That's it. And calculus we did not use because it was not required. Right now, y equal to sine x. If I try to calculate vector representation of a sinusoidal line, but I know the vector representation of any line is I plus y by xj. So will it be same? Certain. This is what is not written in any of the book. What is vector representation of sinusoidal line? What is vector representation of a straight line? I plus y by xj. This is not a complete thing. Complete is xi plus yj. But all right. I means if x is 1, height is y by x. I plus y by xj. What is vector representation of sinusoidal line? Then again it is I plus y by xj. What is y by x? Y equal to sine x. Y by x, if I take a straight line, it is a numerical number y by x. If I take y by x for a line that is y equal to x by a square root of 3, then y by x is 1 by a square root of 3. It's a numerical number, fixed number, not variable. So I plus y by xj vector representation is a fixed vector. But here y by x is variable. If I see y by x for a sinusoidal line, then everywhere y by x is different. If I take at x is pi by 2, then y is 1 and x is pi by 2. If I take little go further, if I go pi, then y is 0 and x is pi. Means y by x is 0. If I take at 90 degree pi by 2, then y by x is 1 by pi by 2. If I take at 0, then 0 by 0 anyway. So everywhere, if I take at pi by 4, then y is 1 by a square root of 2 by pi by 4. That is y by, everywhere y by x is different. Okay, but I am committed to use a vector representation for a line is I plus y by xj. Do whatever you do. Then I politely, silently see y by x for the sinus. When I went ahead and when I'm going ahead to calculate y by x for sinusoidal, y equal to sine x. This is the equation of sine x. If I calculate y by x in a graphical manner, everywhere y by x is different. Looks like y is dependent upon x is y is fx, function over x. Actually, y by x is sine x by x. Makes sense? Y equal to sine x. Y by x is sine x by x. Means numerator varies with varying the denominator. In straight line, y by x is 1 by square root of 3. Means numerator is not varying with the denominator. Always fixed 1 by square root of 3. But here, y by x is sine x by x. Numerator that is sine x, it keeps changing if I keep changing x. Division is how much numerator, how much division y by x, if I take it as division, then per unit of x brings how many unit in y. That is division. I have given many times example. Consider a bag filled with orange and consider a bag filled with orange and consider a bag that is filled with mango. One is orange and one is mango. Okay, now in orange bag there is a 3 orange. This is filled one. Okay, 3 orange, and mango bag it is 12 mango. Okay, now after some time I see orange bag has 4 orange where this has 16. Now if I add one orange to orange bag, then how much I need to add in the mango bag? 4. So 16 by 4 is 4. 12 by 3 is 4. Means per unit orange is 4 mango. Okay, that is division. Okay, I can change division into differentiation if numerator is dependent upon denominator. Numerator is dependent upon denominator. What are you talking about? Consider the orange. In the orange, We have orange, we have three orange bag, where here we have nine in mango bag. Now it has four, then it has 16. If it has five, then it has 25. Looks like, okay, now question is, when it has 5 and it has 25, then how much is the mango per orange? Then 5. If it has 4, then it has mango is 16. How much is the mango per orange? 4. It is varying. Y by X or mango by orange is varying, and it is dependent upon current orange position. If that is the case, where numerator is dependent upon denominator, like y by x equal to sine x by x, numerator is sine of x and denominator is x, numerator is dependent upon x. If you vary x, numerator will vary. In that case, division will transform into differentiation in calculus. Y by x will become dy by dx. You cannot write y by x now. Okay, what is here? Here is, if orange is 5, mango is 25, related as x square if you watch carefully. How much is the mango by orange? It is x square by x. Okay, when orange is 5 and mango is 25, if I add one orange here, how much I need to add in the mango bag? If I add one orange here, it will become 5 to 6. Okay, right now it is 5 relationship. Is that 25 by 5 is 5. If I add one orange here, it will become 5 to 6. Similarly, I have to add 5 there because division is 5. If I add there, it becomes 30. That is not the case. It should become 36. So this is not simple division. Through simple division, I cannot anticipate what will happen if I add one more. Makes sense? In orange, if orange bag has 3, mango bag has 9. If orange bag has 4, mango bag has 16. If orange bag has 5, mango bag has 25. Not 5, 25. I divide, I say 5. Per orange, 5. Now add one more. It becomes 5 to 6. So add 5 here. It becomes 35 to 30. But it should become 36. Normal division is not working because current mango position is dependent upon change in mango. Change in mango is dependent upon current position of orange. Y by x, y is number of mango by x. Change in mango at any particular time is dependent upon what is x. It will fall in dy by dx. Not so if y is x square, normal division will give x square by x. That is x. If orange has 5, then if I add one more, then it will add 5 here. If orange has bag has 6, x square by x. The relationship between mango and orange is mango is x. If orange is x, mango is x square. This is what we have seen. Division of x square by x is x. Means if I add one orange in bag of orange, whatever the orange count is, that much I have to add in the mango. If orange has 10 oranges, at that time x is 10. If I add one more, then I have to add 10 here. Right now, if it is 10, then it is 100. Now, if I add 1 here, it will become 11 and it becomes 110, or it should become 121. So division will not work in a scenario when numerator is dependent upon denominator, and this is what it is. Then what it will be? Y by x will be replaced by dy by dx. Our statement is y by x per unit of x brings how many unit in y. The definition will change to per unit change in x will bring how many unit change in y. See the line. Division is per unit of x, y by x. Per unit of x is how many unit in y. Whereas differentiation dy by dx is per unit change in x brings how many unit change in y. D of x square by x is 2x. It will be 2x. If I add 1 here when orange strength is 10, then I have to add here 20. 21 more or less same. If orange strength is 20 and here it is 400, if I add one more, that is it becomes 21, then I have to add here 40. Okay, not x, 2x. Okay, so this is calculus. So if I'm trying to calculate the perpendicular to the circle, Then first I'll represent the circle through a through sine x line. Then I have to represent the sine x in a vector form, that is I plus y by xj. Y is sine x. This is a formula of a sinusoidal wave. Sin x is depend upon x. Y by x will be transformed into dy by dx. Now it is I plus cos xj. That is the representation of a line that represent y I plus y by xj will become dy by dx. I plus cos xj is the representation of a vector of a sinusoidal. And what are you talking about? I am talking true. When angle is 0 at the beginning, sine will start like this. And when angle is 90 degrees, sine will be flat at 1. This is sinusoidal wave. Now at origin, sinusoidal wave will shoot like this. And when it is 90 degree, it will be flat. When it is 180 degree, it will shoot in downward direction, negative direction. When it is at 0, then I plus cos theta j. Theta is 0. Then it is 1. I plus j. It is at 45 degree. It will shoot when angle is 0. At 90 degree, cos theta is 0. Only I, only flat line will be there. This is exact representation of the sinusoidal wave. Okay, I believe too much time. Take it an assignment to find the perpendicular line to the line that is y equal to sin x. We have found representation of sin x in vector form as I plus cos xj. What is the vector that is perpendicular? I'm sorry. Okay, perpendicular we are trying to find. We will find 30 degree also. What is perpendicular of a vector that is I plus cos xj? If someone finds, then someone has to find the line equation back from the perpendicular. Finding perpendicular is easy. Alpha I plus beta j dot product I plus cos theta j equal to 0. In that sense, alpha plus beta cos theta equal to 0. In that way, alpha equal to minus beta cos theta. Okay, in that way, I'm sorry, beta cos theta equal to minus alpha. Beta by alpha equal to minus 1 by cos theta. I think so, something like that. Okay, beta by alpha means y by x. Y by x, not theta, I'm sorry, x. Cos x, we are taking cos x. So beta by alpha equal to minus 1 by cos x or minus 1 by cos x. If that is the case, beta by alpha equal to minus 1 by cos x. This is the relationship we are getting. What is your vector? Alpha square plus beta square equal to 1. That is another condition. One condition is alpha I plus beta j dot product I plus cos x j equal to 0. One scenario. Another is alpha square plus beta square root equal to 1 because it is a unit vector. First is alpha plus beta cos x equal to 0. Alpha plus beta cos x equal to 0. In that sense, beta by alpha equal to minus 1 by cos x. Okay, what is vector represent? That we will see. Beta by alpha means y by x. Y by x equal to minus 1 by cos x. Okay, y by x. I know that next line that is coming is maybe a curved line, may not be a straight line. So y by x, I will transform into dy by dx. What will happen if it is a straight line? That also differentiation will work. If I know if division is working any place very perfect, I don't need calculus. Still, I can replace division with the differentiation. Differentiation is superset of division. Division will fit into differentiation, no problem. Okay, blindly I can use differentiation instead of division. No issue at all. So y by x, I can write a dy by dx equal to minus 1 by cos x. That is the equation of another line. Dy equal to minus 1 by cos x dx. Differential equation, and you get the equation of the line. We will proceed more on it. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.